Hello everyone, welcome to the Information and Network Security lecture series. This is lecture number 5, and in this particular session we will cover the topics. The first one is the transposition techniques. We will study two. One is the rail fence cipher and transposition cipher using key. Then the working of the rotor machine, and the last one is the stagnography. So the first one is the transposition cipher. Until now we have covered various some of the simplest we can say monoalphabetic as well as polyalphabetic cipher techniques. Now we'll study some transposition techniques. In case of transposition technique, we are just changing the position of the alphabets. We are not making any substitution, or you can say we are just permuting. Okay, so in this technique the given plain text characters are permuted, they are not substituted using various schemes. Now the very first one, the most easiest one, is the rail fence cipher. It's also called as keyless cipher. Now this rail fence is the simplest transposition technique in which the plain text is written on as a sequence of diagonals and then read off as a sequence of rows. So we write in this case we write the plain text character in zigzag way and read row wise. Like for example, we have this message, like we have to encrypt the message catches win matches. This is the message we have to encrypt. Okay, catches win matches. So what we do is we make two rows, okay, and write the message in this way: C A T C H E, zigzag way, catches, then win, matches, and so on. Okay, now after writing this message in this way, we read the first row. So I made two colors, so you can see the green one. So green one is C T H S I, so this comes first, the green part comes first, and this one, the next one, the light orange part, comes afterwards, which is the second row. So this is how we do the arrangement in this case for making the rail fence cipher. Okay, then the next transposition cipher is by using a key. Now this was a keyless rail fence cipher, is a keyless cipher technique, and here we have this transposition cipher using a key. So this is a little bit more complex as compared to the rail fence cipher. Okay, so what we do in this case is we write the message in a rectangle. We arrange the message in form of a rectangle row by row and read the message column by column and permute the order of the columns. Okay, so how do we do this? Like for example, we have this attack early morning, and of course here the order of the column is the key of the algorithm. So I'll show this with this example. Suppose we want to we want to make this we want to use transposition cipher for encrypting this message attack early morning. So how we do this? We arrange the this particular message in 5 columns. So A T T A C K attack, E A R L Y early, M O R N I N G. Now this 2 may be left, so we just insert the bogus characters X and Y, so to make this perfect. Okay, now this is the key 3 1 2 5 4. What does it mean? So I've used different colors for different columns. So this one shows that we have to read this column first. Okay, so therefore this TEMN. Now this is 2, so we read the next column, second column number 2 afterwards. So this is TAOG, then this is the third, this is the fourth, and this is the final 5th one. So this is how we permute the columns. So this key shows how the columns will be read in the sequence. Okay, so this is the transposition cipher using the key. We can also make some more actually permutations. Some more blocks can be used. Okay, so we can make it more significantly more secure by performing more than one stage of transposition, as is shown here. Okay, so here this is one stage of transposition, and this is the second stage. So suppose the message is smile, SMILE, smile. So how in this first case, this S, it goes up from here to here. I'll just take another yellow pen. So it comes here, S comes here, and in the second transposition block it goes here. Okay, M, it comes from here, it goes here, and then comes back here. Okay, so this I, in the first stage it comes here, in the second stage goes here, and so on. So finally this is our final message, that is the cipher text. Okay, so this is how the transposition cipher works. Now next is the rotor machine. Okay, now rotor machine, first of all let us see the description of this. This is a short diagram of an Enigma machine which was used by the German forces. It was based on this rotor machines. So Enigma machine was more complex compared to this rotor machine. Let us understand what the rotor machine is, how we can do encryption using the rotor machine. Now this machine has rotating cylinders with input and output pins. Okay, so we'll have the like this, the cylinder. Okay, this is the cylinder. Okay, I'll just use black pen. So it consists of a cylinders. This, okay, the cylinders are there on and on this cylinders we have the alphabets A, B, C, D up to Z, okay, which are written here. Okay, this is how it is written. So all the alphabets are written here. Each cylinder has 26 pins connected in a specific way. When a key is pressed, so if we can consider this diagram, it is not a proper one but just a rough estimate. So if there are many keys here, as you can see, if you press a key, what will happen? An electric signal will flow through the cylinder, creating a substitution for that letter. Suppose I press A, okay, and with respect to that arrangement, some of the one of the cylinder, the first cylinder, it may have multiple cylinders. So when the signal goes to the first cylinder, it may activate some alphabet based on the settings. It may activate C, it may activate any of the other alphabet. Okay, and after every press, the cylinder rotates by a particular speed, which only the persons who are designing, who are encrypted and decrypted, they know it. With each key press, the cylinder rotates, creating a different substitution. So with every key press, we get a different substitution. Suppose I am pressing A first, I may get C. After the next pressing A, I may get something else, not C. Okay. Now after 26 alphabets, it returns to the starting position. Okay, so it resets after 26 alphabets, creating a period of 26 for the substitution cipher. Now we can have more security by using multiple cylinders. If we connect them, the output of one becomes the input of other, such that so when we are pressing the key, the output of key becomes the input for the cylinder, and the first cylinder, output of first cylinder becomes the input for the second cylinder, and so on. Okay. Now this rotor machine, as I told, that it is a simplified version of the Enigma machine which was used by German forces. Now with 3 cylinders, we can have different 26 into 26 into 26, 17,576 different substitutions, okay, used before the system again repeated itself. So this is very extremely secure rotor machines. Okay. The last topic of this chapter is of this session is the stagnography. Now stagnography is different from cryptography, because in stagnography we don't use any key, and the actual message is hidden in some other message. Okay, so we write a message, okay, and what we want to convey may be inside that particular message itself. Okay, so what are the various ways? The methods of stagnography hides the given message in other message. So we may be the sender may send a message, but reading that message, any adversary may not know anything, but the receiver, he knows how to get the actual message from that particular message. So we can hide the message, okay, so or hides the message using various means, so that only the intended recipient gets the message. Okay. A simple form of stagnography can be arranging the words or letters within a message. Okay, like we can send a message, okay, and tell the recipient that select the first alphabet of every word. For example, in this let us take this is the text message. Okay, this is the text. So this is the first A, then take S, the first alphabet, then take F, then take O, then take S, and so on. So take out the first alphabet from every word of this message, then you will get that particular message. So this is one form. There may be other forms also. So some of the forms of stagnography, as we can see, character marking. Okay, character marking means what? We send the message, okay, and after sending the message, we overwrite those alphabets what we want to send the message. Okay, like suppose suppose the message is character marking. So I want to send this C. I want to mark. So this C is actually marked twice. Okay, so whatever character or whatever message we have to send, we just write it twice or thrice. Okay, so it is only when it is seen thoroughly, then only it will be revealed. Then we can use invisible ink. Okay, there are many chemical substances when through which if we write and they are not visible, but when some chemicals are poured, then the message it becomes readable. Then we can use pin punctures. Pin punctures is what we have this black, suppose we have this paper, pins, okay, we just put the pin punches. So if this is A, this is V and A, okay. Pin punches cannot be seen, but if we put them on sunlight, on some light, then we can see it, okay. So this is V and A written, so it cannot be seen directly, it has to be exposed to some sunlight or some other light. Then we have typewriter correction ribbon, okay. So typewriter correction ribbons can we can make a correction, but the alphabet there is already there, okay. So when it is seen in extreme intense light, then this things, the message can be revealed. So there are other forms of stagnography also. So this is how stagnography can be done, okay. So that's all for this particular session. Thanks for watching.